In this video, I will be doing all of the 2014 free response questions from the AP Calc exam. Question number 1. So it says grass clippings are placed in a bin where they decompose. For time 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 raised to the t, where A of t is in pounds and t is measured in days. Find the average rate of change, A of t, for A of t over the interval 0 to 30. Indicate units of measure. So as you know, the average rate of change is f of b minus f of a all over b minus a. But we can't write that here because we don't have a function f. So we're going to write A of 30 minus A of 0 all over 30 minus 0. And we're going to find those values. Now this is a calculator question because it's question number 1. So questions 1 and 2 are always calculator questions. So I've already put these in, my A of t in for y1. So I'm going to go to second table. And I'm going to plug in 30. Oops. Make my independent variables so I can ask. I don't know why it wasn't set that way. And I'm going to plug in 30 and I get a certain y value. Okay, so my y value is 0.78293. And when I plug in 0, I get 6.687. All right, so I'm going to subtract those two. All right, so if I want to find more decimals, which I probably need in this example, I'm going to do it like that. So I'm going to have 0.782928. And then my A of 0 is going to be 6.687. And then I'm dividing by 30. Okay, so putting those into my calculator, I end up getting negative 0.197 or negative 0.196. And this is in pounds per day. All right, so pounds was the numerator, which was A of t, and then t was in days. All right, B, so find the value of A prime of 15. All right, again, since this is a calculator question, you don't want to spend a lot of time finding derivatives if you don't need to. So what we're going to do is we're going to do math 8 on our main screen, which is n deriv. Oops, I did math 9. And I'm going to do bars, y bars function. It was n for y1. And I'm going to evaluate it at x equals 15. So I plug in. So I end up getting negative 0.164. So I write what I put into my calculator. I found A prime of 15, and I got negative 0.164, or negative 1.163 if you truncated. And it says, using correct units, interpret the meaning of the value in the context of the problem. Okay, so if I'm finding a rate, where my original A of t was in pounds and t was in days, then this is going to be the number of pounds per day where my grass clippings are decomposing. So I have to write that out using a sentence. Okay, so I would say the amount of grass clippings decomposes at a rate of 0.164 pounds, or you could even say decreases at a rate of 0.164 pounds each day at time, and you always have to say at whatever time this was. So at time t equals 15 days. All right, so part C. Give myself some more room here. So it says, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the time 0 to 30. Okay, so this is average. So you're thinking of two different things, average rate of change or average value. In this case, it's an average amount of grass clippings. And this was amount of grass clippings, A of t. So we're finding the average value. So I'm going to do 1 over 30 minus 0, 0 to 30, and I'm going to have a of t dt. And again, a of t is already set up in my calculator, so I'm going to do math 9. I'm going to do vars function y1, or y vars function y1, and I'm going to go from 0 to 30. Okay, I still have that 1 over 30 out front, so I'm going to divide my answer by 30. So I end up getting 2.753. What did I do? A of t. I think I did everything right. I have an answer that I got before, and I had 12 point something. So let me make sure I have everything right. I have 6.687.93 t, 31 to the t. I did math 9. I put my vars, y vars function y1. I went from x values 0 to 30. Yep, and then I divided by 30. Oh, okay, so we're finding the time. Hang on. So I end up getting this answer. So I get all of this is equal to 2.7, what was it, 53? I'll save it. 752.635. And I'm going to store that. And I don't want to call A since I have A of t in my problem. So I'm going to say let B equal this number. Okay, so I'm going to go ahead and store that value. Okay, and the question was, find the time t for which the amount of grass clippings is equal to the average amount of grass clippings. Ugh, tongue twister. All right, so we want to find the time t where this happens. Okay, so we're going to go ahead and we're going to go back to our graph. And under y equals, I'm going to put y equals b. Okay, so we can graph both of them and we're going to find where they intersect. So when I graph, I do want my time to be on 0 to 30. And the amount of grass clippings, I don't know, that could go up pretty high. Let's keep it how it is right now, and we'll play around if we need to. So we have that. So we're going to find where these two things intersect. All right, so when I do second trace intersect, I end up getting an intersection point of 12.415, okay, or 12.414 if you truncate. So that's the value for t, and that's exactly what I want. So I need to show that I've done this in my calculator. So I'm going to set it up, and I'm going to say that A of t equals 2.75, well, let's just say b. And then now we can say, oh, well, we found that using our calculator, and t was equal to 12.415, and my units are in days. And then part D, it says for t is greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Okay, so after we get to 30, we use the linear approximation instead. So use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. So it's decomposing, when do we only have 0.5 pounds left? Okay? So don't get scared. Whenever you see a linear approximation, all it is the equation of a tangent line. So we need the point, and we need the slope. Okay, so we're saying at t equals 30, so we have 30. And when you plug in 30 into your amount, right, I don't know if we did that earlier, didn't we? We find that value. It was 0.782928. And then our slope would be a prime of 30. Which we haven't found. So we would go ahead and do that using our math 8 again. So math 8, oops, clear. Let me get out of here. Math 8 vars, y vars function, y1, and we're evaluating it at x equals 30. So we get that value, and we could probably store that, right? So we'll store it just in case, alpha c. So I have negative 0.055976, and I've stored as c, I think. All right, and then I write my equation of my tangent line. So I'm going to have y minus y1, and I could be kind of precise and store that value. I could just plug in 30 into my original and store it, but I'll go ahead and shortcut it for now. All right, and then I'm going to have x minus 30 like that. So I'm going to go ahead and kind of simplify. So I'm going to have y equals negative 0.055976x. And when I distribute here, I'm going to have plus 1.67928. And then I'm going to add that 0.782928 number over. And I'm going to end up getting, so instead of that number, I'm going to get 2.462208. All right, and let's write this using variables that we've used in the problem. Okay, so really L of t is really an approximation for A of t, the amount in the bin, but this is for values that are greater than 30, what it's saying. All right, and this is equal to negative 0.055976 t, right, x values t, plus 2.462208. So we want to know when we end up having 0.5 pounds of grass clippings remaining in the bin. So that's going to be our amount, our L of t or A of t, whatever you want to call it. So I have 0.5, and we're solving for t, right? Now ideally you're going to have all these numbers stored in your calculator, and a lot of you guys have the calculators where you can go up and grab. Okay, so as I divide, I end up getting t equals 35.054, and this is in days. Okay, and this should make sense because we're talking about a time that's greater than 30. So if you're getting something that's less than that, you've probably done something wrong, okay? So that's our answer. So if we talk about our points, we get 1 point for part A for having the answer, including the units. If you didn't have the units, you would not get that correct. Part B, we get 1 point for finding A prime of 15 correctly and 1 point for the interpretation, so writing out what's happening using units. Part C, we get 1 point for finding that average value, and we get 1 point, or setting up the average value, and 1 point for the answer. And then part D, you get 1 point for finding an expression for L of t, which is our linear approximation, and 1 point for finding 0.5 is equal to L of t, or replacing L of t with 0.5, I guess, and then 1 point for your answer. Okay, so the next problem, we have let R be the region enclosed by the graphs of f of x equals x to the fourth minus 2.3x cubed plus 4, and the horizontal line y equals 4 as shown in the figure. Find the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. So if we're rotating around the line y equals negative 2, so they kind of just start out with a hard one right here, don't they? Usually they'll ask area first. Okay, but recently, on the most recent tests, they are pretty difficult. So if I'm rotating around the horizontal line y equals negative 2, I know that it looks like an x-axis line. It's a horizontal line. So I'm going to integrate with respect to dx. So that means I'm going to have x values for my limits of integration. So from there to there, so it's 0 to whatever this is. I need a pi out front. And then I'm going to have my big R minus my little r. Okay, so I went ahead and put these into my calculator. Maybe it went away. I got to put it back in. All right, so I'm going to have x to the fourth minus 2.3 x cubed plus 4. Oops, plus 4. And And then my line y equals 4, and I'm finding where they're crossing. So I'm going to hit graph, and I'm going to do second trace, intersect. Okay, and I can tell they're crossing at 0 already, because if you plug in 0 for the first equation, you do get 4. But I don't know about this other point. All right, so it's crossing at 2.3, 4. So that's nice. I don't have to store it, because it's a nice value. So I'm going from 0 to 2.3, and I need my outer radius minus my inner radius. So my outer radius goes all the way from the axis of rotation to the outside of the shaded region, and my inner radius goes from my axis of rotation to the inside of this shaded region. And all it is just the top minus the bottom. It's the length, just like we've talked about before. If I'm finding the distance from 10 to -1, it would be a total of 11, 10 minus a -1. Or 10 to 7 would be a total of 3, right? 10 minus 7. Top minus the bottom. Okay, so my big R, as I call it, would be the top line, which is 4, minus the bottom line, which is -2. So I get a total of 6. And my little r ends up being the top line, which is that f of x function, minus the bottom line, which is -2. So we get f of x plus 2. And you can call this R1 because, you know, we talked about R, the region, in the original. Whatever you want to do. So I'm going to have my big R squared, so 6 squared, minus the little r squared, f of x plus 2 squared. Don't forget the squares. A lot of people forget that. All right, and it's a calculator problem, so we just put this into our calculator. So we would use math 9. I would use y1 in my calculation, and I went ahead and I did that. And your answer should be 98.868, or if you truncated, it would be 98.867. Okay. Part B says region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So as you can see, in the last couple years, these problems have been getting much more difficult than they used to be. Okay, so if we're going perpendicular to the x-axis, we're taking our chalks like this, right? So our x is changing. So we're integrating with respect to x. Okay, and so we have this distance right here, and we're going to have a shape coming up off of that cut. And it's going to be an isosceles right triangle with the leg in R. Okay, so that means that we have a 45, 45, 90 triangle with one of the legs there. Okay, so we know the area of a triangle is 1/2 base times height. So our base and our height end up being the same thing. So I'm going to have the volume is equal to the integral of the area of the cross-section, which is going to be 1/2 base times height, which are the same thing. And what that distance is just the line 4, right? So I'll call that B. It's going to be 4 minus f of x. Okay? So that's what we're putting in, 4 minus f of x. And we're squaring it. And it still goes from 0 to 2.3. That looks like a 23, but you get it. All right, and I went ahead and found this as well, so you could math 9 it, because it's a calculator question, and you would get 3.574 or 3.573. And then the last part, part C, says the vertical line, x equals k, divides the shape into 2 equal areas. So this area and that area. Okay. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So you can do this lots of different ways. You could use the fact that you have half of the whole area and then set it equal to 1 of the halves. Or you could just say, well, the red part is equal to the blue part and set up the equations for both of those. So if I'm talking about the red portion, when I set up its area, it's going to be from 0 to whatever k was. And then we're going to have the top minus the bottom. So top curve minus the bottom curve. So I'm going to have the 4 minus f of x. That has to equal the other portion, which is k to 2.3, but it's still the top minus the bottom, same thing. And that would be enough, okay? So your points for this problem, for part A, you get 2 points for your integrand. So the integrand is this part inside here. So I'm guessing for each, the 6 squared and the f of x plus 2 squared, you get a point for each of those. You get 1 point for your limits, meaning the 0 to 2.3, and you get 1 point for your answer. For part 3, you get 2 points for the integrand. So probably because the 1/2 or the squared or something like that. 1 point for the answer. And the last one, you get 1 point for finding the area of one of the regions and 1 point for setting up a total equation. So if you had gotten either this or this, you would get 1 point. And then you get the second point for setting it equal to the other one. Question number 3 says the function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. So let g be the function given by g of x equals the integral from -3 to x of f of t dt. Okay, so this is an accumulation function. So when you see these on the AP exam, you're often going to find areas of triangles or semicircles or whatever. So in this case, it looks like triangles. So the first part says find g of 3. So we know in order to find g of 3, 3 is our x value. So we're plugging in 3 for x in that equation above. So that limit of integration goes from -3 to now 3 instead of x. All right, so what this represents is some different integrals from -3 all the way to 3. So let's see, here's 2, so 3 would be right there, okay? So we're going to have a positive value and we're going to have a negative value. All right, so as we're doing this, we have the area of the first triangle is 1/2. Its base is 5, it looks like, and the height is 4. And then the negative amount, we're going to have plus, or minus in this case, a 1/2. Its base is 1, and its height, as you can see, the slope of this line, it goes down 4 over 4, or not over 4, over 2. So the slope is down 2 over 1. So if you go down 2 and over 1, you're going to be right at -2. So that's the point 3, -2. So its height then is 2, or -2, All right, so we end up getting half of 20 is 10 minus 1, so we get a total of 9. All right, part B. So it says on what open intervals contained in -5 to 4 is the graph of g both increasing and concave down? So if we're saying increasing and concave down, we know that g prime has to be greater than 0 for increasing, and g double prime has to be less than 0 for concave down. So we write that down. And it says give a reason for your answer. So let's see. So we're going to go ahead and find g prime and g double prime. So if I have g of x is equal to the integral from -3 to x of f of t dt, when I take the derivative of that, right, we use the fundamental theorem of calculus. So we get g prime of x is equal to, this x will basically replace any t in the equation. So we're going to have f of x. So g prime of x is actually equal to f of x, which is the graph that we have. And then g double prime of x then is equal to f prime of x. So if we're looking above, sometimes it helps to use a sign chart to kind of gather our thoughts. G prime is equal to f. And we look at this chart, or this graph up here. We know we're on the open interval, -5 to 4. So we actually don't include those points, but that's fine. And we want to know when f of x is positive or negative. So in other words, it's above the axis or below the axis. So we're above the axis, below the axis. And it's only hitting 0 at -3 and 2. So we're above, below. So what that means is for the graph of g increases, and then decreases. Okay? So when we look at the sign chart for -5 to 4, for g double prime, which is equal to f prime, we want to know when f prime is positive or negative. So what that means is when is our slope positive or negative. So our slope is negative, then it's positive, then it's negative all the way to 4. Okay, so our places where it's changing, So the places where f prime is equal to 0 or undefined would be here, here, and that's it. So we're going to look at critical values, or for points of inflection, we often call it points of interest, of -3 to 2. Oh, not -3 and 2. What am I talking about? -3 to 0. So maybe I'll kind of draw that off to the side a little bit so I'm lining up these numbers. Okay. So when I said it was negative, positive, and then negative. So what this means for the graph of G is that G is concave down, then it's concave up, and it's concave down. Okay? So we want where we have both increasing and concave down. Now the graders are not going to grade these sign charts, so we should write what's happening. So we should say G prime is greater than 0 on -5 to -3, and also on -3 to 2. And G prime is less than 0 on 2 to 4. G double prime is greater than 0 on -3 to 0. And G double prime is less than 0 on -5 to -3, union 0 to 4. Okay, so as long as we've written, this part, right, and we've written this part, we're good. We've described everything that's in that sign chart. All right, so we're looking for where it's concave down and also increasing. Okay, so increasing would be here and here. Concave down would be here and here. So where do they overlap? It looks like they only overlap from -5 to -3. That one's very clear. But also for a little tiny bit right between 0 and 2. So if you look here, see how we have red in both of those spaces. So from 0 to 2 as well. So I'm going to say on -5 to -3 and also 0 to 2, G is concave down and increasing, because G double prime is less than 0 and G prime, is greater than 0. So you can write those in if you would like. Okay, so those are the explanation, and that would be enough to give a reason for your answer. That would be done. All right, so the next part, it says, the function h is defined by h of x equals g of x over 5x. Find h prime of 3. So they do these a lot on these problems. They give you a new problem, and usually you need to use the chain rule, quotient rule, something in order to take the derivative. So for part C, if you have h of x is equal to g of x over 5x, and you're asked for h prime, we do the quotient rule. So quotient rule, low d high, minus high d low. So the derivative of the low, or the derivative of the bottom is 5, all over the square of what's below, so 25x squared. And we plug in. So we find h prime of 3 by plugging everything in. So we're going to have 15 g prime of 3 minus g of 3 times 5 all over 25 times 9. Okay, and g prime of 3, we already talked about that. G prime of x is equal to f of x. So really this is going to be f of 3. And g of 3, I think we already found, right? Part A, g of 3 is 9. Okay, so we're well on our way. So if we look at f of 3 is going to be the point that's right here. And we talked about that. F of 3 is going to be -2. So we're going to have 15 times -2 minus 9 times 5 all over whatever 25 times 9 is. I'm guessing I can reduce eventually. So I'm going to have -30 minus 45 all over 25 times 9, and I'm kind of leaving it like that for a reason, because I'm going to reduce my fraction. So let's see. -75 and 25 can reduce down to -3, and then -3 and 9 can reduce down to -1/3. So we got to do what we got to do without a calculator, right? So don't multiply everything out just to reduce it in the end. So we get -1/3 for h prime of x, or h prime of 3. All right, and then part D, same idea. Now it says the function p is defined by p of x equals blah, blah, blah. Find the slope of the line tangent to the graph of p. So whenever we see that, remember we want a point and we want the slope. So our point is going to be plugging in -1. So we're going to have p of -1 equals f of -1 squared, which is 1, minus a -1. So it's going to be f of 2. So looking at our picture, f of 2, do you see it? It is equal to 0. Oh, I'm just finding the slope. I'm not finding I thought I was finding the point. That's fine. If I was finding f of 2, it would be 0. And then the slope is going to be p prime of x, which involves the chain rule. So a lot of you still have trouble with the chain rule, so be very careful. I always think about it if it was like sine. So if I had sine of x squared minus x, you know how to take the derivative of that. It would be cosine of x squared minus x times the chain, so times 2x minus 1. Well, it's the same thing when you have f of whatever. So it's going to be f prime of x squared minus x times the chain, so times that 2x minus 1. Okay, so always think about like sine or cosine or something when you're doing those. So I'm going to have p prime of -1 is going to be f prime of -1 squared is 1 minus a -1 is 2, which we just said, times 2 times -1 is -2 minus 1 is -3. So we get f prime of 2. What is f prime of 2? So let's see. F prime of 2 is going to be the slope at the point 2. So what is the slope of this line? We go down a certain amount and over a certain amount. It looks like we go down a total of 8, and we go over to the right by 4. So my slope is -2. And then times -3, so we get a total of 6. And that one did just ask for the slope of the tangent line, so it should just be 6. That's all you need. If it asks for the equation of the tangent line, which is what I thought it was going to ask, you would need the point as well, right? So we have the point. We plugged in -1 and got 0. So we'd have y minus 0 equals 6 times x minus a -1, so x plus 1. Or you'd have y equals 6x plus 6. So if it asked you to go a step further, just make sure you would need your point and the slope, and you would go a little bit further. All right, let's look at the scoring on this. So for part A, you get 1 point for your answer of 9. For part B, you get 1 point for your answer, which is -5 to -3, and also 0 to 2. And then 1 point for the reason. So you would need to say something about G is increasing and concave down, G prime is equal to F, G prime is positive, G double prime is negative, something like that. C, you get 2 points for finding H prime of X correctly. So I don't know how they separate those 2 points, maybe the numerator and denominator or something. 1 point for the answer of -1/3. And then part D, you get 2 points for finding P prime correctly, so probably F prime times the chain. And then 1 point for your answer of 6. All right, so question 4 is a chart problem, which are very common on the AP test. So it says train A runs back and forth on an east-west section of railroad track. Train A's velocity measured in meters per minute is given by the differentiable function v sub a of t, where time t is measured in minutes. So I'm guessing they're going to have a v sub b of t, right? So in part D, you can see that. Selected values of v sub a of t are given in the table above. Okay, so find the average acceleration. So this was the velocity function, right? So velocity. So if we want to find the acceleration, we're going to take the derivative. Okay, but we don't have a function that we can actually take the derivative of. We just have this chart. So a derivative is the same as slope, right? So we're going to approximate our slope at a certain value. So and it says find the average. So this is the average rate of change, really. It's the rate of change of velocity, right? Okay, so we have a certain interval. It says from 2 to 8. Now, if it just said approximate at 3.5, right, you would use these two values and you would find the slope between those 2 points. But now it's saying find the average acceleration over the entire interval. Well, part of the interval. There we go, 2 to 8. So we're going to find the average rate of change. So we're going to do basically f of b minus f of a all over b minus a, but we're going to write it as v of 8 minus v of 2 all over 8 minus 2. And I guess we should put our little subscripts in. Although that is very annoying that they do that, right? So we get -120 from our table minus a 100 all over 6. So we get negative 220 over 6, which reduces to negative 110 over 3. And usually these will say something like using the correct units, but it doesn't. So you probably don't get a point for your units, but I would still put them in. Okay, so your units for the velocity were meters per minute. So the top is in meters per minute, and the bottom is in minutes. So if we do meters per minute, and we divide by minutes, right, it ends up being meters per minute squared because we're multiplying by 1 over minute, which makes sense because it is a acceleration, right? Just like feet per second squared or miles per hour squared or whatever. All right, part B. Do the data in the table support the conclusion that train A's velocity is a negative 100 meters per minute at some time t, with t being on 5 to 8? Give a reason for your answer. So usually when they're asking about, let's see, some kind of interval, like 5 to 8, there are 2 theorems that you would want to think about. Okay, and we've talked about these in class a lot. You would want to think about the mean value theorem, and you'd want to think about the intermediate value theorem. Okay, so in this case, it's talking about train A's velocity. Okay, velocity is what you were given. It's like your f of x. Okay, it's not asking for like f prime to equal something, the derivative. It's not asking for the acceleration to equal something. It's asking for the actual value. Okay, so I think this is an intermediate value theorem. So let's talk about this. So between 5 and 8, what we're saying is that at 5, we are at a height of 40, and at 8, we're at a height of negative 120. Okay, so our velocity goes from 40 to negative 120. Okay, what it's asking is, does it have to cross at v sub a of t equals negative 100 meters per minute? So does it have to cross that line? Okay, and our answer is that yes, it does. It has to cross that line because it has to be a continuous function. So if you think about velocity in general, right, you're never going to go from 55 miles per hour to 60 miles per hour without going through every single one of those values between there. Okay, and it's the same for this. We can't go from some meters per minute, so 40 meters per minute, all the way down to negative 120 meters per minute without going through negative 100 meters per minute. So yes. So we would need to write that out. So we would need to say v sub a is, so how do we know it's continuous? I guess in the problem it said that it was differentiable, right? And that's not important really in the intermediate value theorem, but it is important to say that it's continuous. So differentiable. So v sub a is continuous then. But you could also kind of write out what I did and say, well, clearly the velocity is continuous because you can't skip from one velocity to the other. I mean, that would be fine. So it's continuous. We always need that stipulation in order to use intermediate value theorem. And then we'd say something about how v sub a of t can equal 100 or negative 100 for some t where t is between 5 and 8 by the intermediate value theorem. Oops, there we go. And that would be enough justification. All right, so kind of tricky. So whenever you see like an interval, 5 to 8 or whatever, and it's saying, does this support the conclusion? Think about those 2 theorems, mean value theorem, intermediate value theorem. And this one had nothing to do with the derivative, right? It had to do with the actual values. C says at time t equals 2, the train A's position is 300 meters east of origin station, and the train is moving to the east. Okay, so this is kind of confusing. Let me draw a little sketch here. So let's say we have the origin station, right? Very cheesy. And at time 2, you're already at 300 meters. So this is really like your starting position. So what we would write then is the position, so usually S or X or whatever, of train A at time 2 is equal to 300. So we know that.
and then we're going to have some kind of accumulation. We're going to have some kind of displacement that we're going to add to this. So it says write an expression involving an integral that gives the position at time t equals 12. So use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. All right, so basically if I'm finding the position at times t equals 12, I need to use that initial condition of 2. And you can write this a couple different ways. The way that we've talked about it in class is we've said, oh, it's easiest if we write from 2 to 12 integrating the velocity function, and that gives you the antiderivative, which is the position function of evaluated at 12 minus the position function evaluated at 2. So that's perfectly fine. Okay, when we just have a random t value, so it's set for any time t, then a lot of times the AP test will write s of a of 2 or 300 plus 2 to t, and then do v sub a of x dx or something like that. Okay, so this one we actually do have the number though. We know we're evaluating at 12, so I would just set it up like that. All right, so this part we're going to find with the trapezoidal rule, and this part is already 300. Okay, so the trapezoidal rule, it's saying with 3 subintervals. And if you look, if you sketched all of this out, you'd have 0, 0, you'd have 2, 100, you'd have 5, 40, you'd have 8, negative 120. Let me write these numbers in, actually. We'll use it. And then you have 12, 150, and there's actually like 4 different partitions. Okay, so it's telling you 3 subintervals, and that's because we're going from 2 to 12, so we're not worried about that first one. So we're going to have 2, 100, and our trapezoid is formed by going to the 5, 40. So see, that's the first trapezoid. Now the middle trapezoid is really weird. It's not really a trapezoid because it crosses the axis. So we go from 40 down to negative 120. And then we have that width. So it's really kind of like 2 triangles, but we'll still use the trapezoidal rule formula. And then this next part would go from negative 120, I don't know why I have this dot here, 8, to negative 150. So it would look like this, and that would just be a negative amount for its trapezoid. Okay, so you can sketch it out if you need to, or you can just use the formula. Just know that it's not the same formula as maybe you had in your notes, because there's not a common width. So the first width is 3, the next width is 3, the last width is 4. So be really careful. Don't pull out like a common width. So we're going to have 1/2, the width is 3, meaning I'm saying width, but it's really the height of the trapezoid. It's just on its side, right? This distance right here. And then we're going to have b1 plus b2 is going to be 100 plus 40. And this is all a non-calculator question, so it gets a little complicated. So 1/2 times 3, and then I'm going to have 40 minus 120, and I'm going to have 1/2 times 4, and I'm going to have negative 120 plus negative 150. And all of that is equal to s sub a of 12 minus 300. Okay? And I find this. So like I said, a little complicated. So I'm going to have 140 here. And when I take half of it, I get 70 times 3, so I get 210. And then I have, let's see, negative, is that right? 40 minus 120. So negative 80 times 1/2 is negative 40 times 3 is negative 120. And then plus, let's see, negative 270. But I can do 1/2 of 4 at least, so I get 2. So I have negative 540. And it equals the part above, right? So let's see, positive 90 minus 540. So we get negative 450. Lovely, right? Are you freaking out that you're like, oh my gosh, I can't believe I couldn't have my calculator? And then you add that 300 over. So s sub a of 12 ends up being negative 150. And then its units, right, if it's a position, would be in meters. So negative 150 meters, meaning it's 150 meters like left of the origin. So we would say 150 meters west of the origin station. All right, so it does say, so we use the trapezoidal sum. It says approximate the position of the train. It doesn't really say like using correct units, say what's happening, but I would say something about at time t equals 12 minutes in there. So we always want to kind of explain in full what's happening. At time t equals 12 minutes, the position is train A is 150 meters west of origin station. All right, and then part D. So it says the second train, train B, travels north from origin station. Okay, so we have train A is going north, of origin station, or train B, I guess in this case, right? At time t, the velocity of train B is given by v of b equals negative 5t squared plus 60t plus 25. And at time 2, train A, or the train B is 400 meters north of the station. So we're going to say the position of train B at time 2 is 400 meters, but now we know it's on the north-south line. Find the rate in meters per minute, the rate at meters per minute at which the distance between train A and train B is changing at time t equals 2. So hopefully you guys kind of recognize what's happening here. We have a right triangle, and we have like the distance for B, the distance for A, and we're trying to find this right here, okay? So I'm going to call this A and this B, really. I have a right triangle, so I'm going to set it up using A squared plus B squared equals, we'll just call that C, right? C squared. So when I do 2A dA over dt, it's a related rates problem. Do you guys all recognize related rates? We've done several of these. And the reason we know is because it's talking about the rate in meters per minute, so it's per time, which kind of gives you a clue that you were doing that. This is a hard question, though. And we can divide out by 2 everywhere, so the 2's go away. Oops, not C. 2's go away. And we plug in what we know. So we're like, okay, well at time 2, we know that A, that distance, A, is, what did I say before? 300, right? So I'm going to plug in 300. And we know its rate of change at time 2. Do we? I think it was 100. Where was it? Yeah, from our chart up there. Yeah, we know this. We know the velocity at time 2 is 100 for train A. And then we know B, we know its distance is going to be 400 because we were given it's right here. And then its rate of change is, let me think, where did it say that? The velocity of the train B is given by V of B, so we got to find it. So we have VB of 2 is going to be negative 5 times 2 squared, so 4, plus 120 plus 25. So negative 20 plus 100, so it ends up being 125, right? So we found that. And then C, we don't know, but we do know that we have 300 and we have 400. So surprise, surprise, 3, 4, 5 right triangle, it's 500. How nice of them. All right, and then we want to find this, oops, I wrote dB over dt, it should be dC over dt. See, I make mistakes too. And we find all of this. So we have 30,000, right? Add 2 zeros there. We have 125 times 4 would be, and lots of math here. Can't even, so 100, 400, 500. Okay, so we're going to get 80,000 over 500. So 800 over 5, 160. You could do that off to the side if you needed to, and that's in meters. Let's see, it's a rate of change of the position, so meters per minute, it's the velocity, right? So 160 meters per minute would be the answer. So a little bit complicated. Love that. All right, so now our scoring for this. So for part A, you get 1 point for just having the average acceleration. A lot of times they'll say average acceleration with units. So if you didn't write your units, you wouldn't get the point. So we're good there. For part B, you get 2 points. So for recognizing that V sub A is smaller than negative 100 and V sub A of 5 is bigger than negative 100. So we have to go through that. So maybe I should have been a little bit more specific with that, saying that negative 100 is between those two, but I did have that little graph. Part C, you get 1 point for your position expression. So the fundamental theorem of calculus, 2 to 12, plus the initial condition. 1 point for having the correct trapezoidal sum. I think they would give you the points actually if you just have the setup from what I hear. But you would need that number anyway to get the position at time t equals 12. And then part D, you get 2 points for the implicit differentiation of the distance relationship. In other words, like recognizing that you had a related rates problem and then taking the derivative using time. And then 1 point for your answer of 160. All right, question number 5 says the twice differentiable function f and g, functions f and g are defined for all real numbers x. Values of f, f prime, g, and g prime are all shown in the table above. Okay, so a lot of calc teachers like to present their information in the table. As you guys know, I like to do the simplified number line, which they don't grade, but it's still good to see. So it says for f prime, between negative 2 and negative 1, we have a negative slope, or a negative values for f prime, which is a negative slope for f. And then from negative 1 to 1, it's negative. Oops, that's a 1 there. And then from 1 to 3, it's positive. Okay. And at each of these locations, at negative 1 and 1, our slope is equal to 0. But at negative 2, our slope is equal to negative 5. And at 3, the slope is 1/2. Okay, so when I'm talking about slope, I'm talking about f prime of negative 2 is negative 5. All right. So what this means is f decreases, it tapers off to a slope of 0, it decreases again, and then it increases. So it would look something like this. Okay. So part A says find the x-coordinate of each relative min of f on the interval negative 2 to 3. Justify your answers. Okay, so it looks like our relative min, there's only going to be one of them, and it would be right here at x equals 1. Okay, so we need to justify that. So we can't just use the chart because no one looks at the chart. Okay, so we would say like x equals 1 is where we would have a relative min. So maybe I should say relative min at x equals 1. And then our reasoning is because we change our sign from f prime, like f prime changes sign from negative to positive. Okay, you could also justify this by looking at the second derivative, but we don't have the second derivative in this table. So sometimes you'll be able to use these chart problems and you'll be able to say, oh, well, I know f double prime is positive, which means it's concave up, therefore there's a minimum. So look for things like that as well. All right, let's see. So part B, it says explain why there must be a c between negative 1 and 1 such that f double prime of c is equal to 0. Okay, so that's giving us some kind of interval. And usually when we have an interval and we're trying to prove that we have a first derivative, second derivative, whatever equals 0, we usually need to use the mean value theorem or Rule's theorem. So in this case, I'm going to use the more specific one, Rule's theorem. And I want to see if I have, well, actually I can't use Rule's theorem because I don't know if f prime is equal on that interval. So we're going to go ahead and use the mean value theorem. Is that what I want? Let me think. Okay, so let's go ahead and do f prime of 1 minus f prime of negative 1 all over 1 minus a negative 1. Okay? So we're going to find that. And we actually have these values. Okay, so they are in our chart, and they're actually equal to 0. So we could have used Rule's theorem, I'm sorry. So we get 0 minus 0 over 2 is equal to 0. Okay? So we've used the mean value theorem or Rule's theorem, as we know. And we can write out, we need to write out our stipulation. So we need to say that f prime is differentiable because we knew that it was what we call twice differentiable, meaning we can take the first derivative and the second derivative without any undefines. And because of that, if something's differentiable, it's also continuous. So as well. Therefore, there is at least one value of C on the interval -1 to 1 such that, or where, f double prime of C is equal to 0. So it's the mean value theorem, or like I said, Rolle's theorem, just using f prime instead of f of x. All right, and then part C, it says the function h is defined by h of x equals natural log of f of x. Find h prime of 3. Go to the next page. Oops, there's no next page. Extend. So if I have h of x is equal to natural log of f of x, and I'm trying to find h prime of 3, then I want to find h prime of x first. So I do 1 over f of x times the chain, which is f prime of x. So h prime of 3 is going to be 1 over f of 3 times the chain, which is f prime of 3. So we look in our chart at 3, which is here. So f of 3 is 7, and f prime of 3 is 1/2. So we have 1 over 7 times 1/2. All right, so we end up getting 1 over 14. And then part D says evaluate -2 to 3 of f prime of g of x times g prime of x dx. All right, and this is something that maybe you don't recognize at first. You're like, oh, this seems complicated. How do I do this? Okay, but what you need to realize is that this is the chain rule, right? And the opposite of the chain rule is a u substitution. So if you let u equal g of x, right, du then would be g prime of x, and you could go all the way through that problem. Okay, so what we're saying is we're trying to, when we do the antiderivative, it ends up being f of g of x, like the chain rule. And it goes from -2 to 3. But you could do all the steps of the u substitution if you're confused on that. All right, do you guys see how if you have f of g of x, when you take the derivative, it's f prime of g of x times g prime of x. It's from the chain rule. All right, so we do f of g of 3 minus f of g of -2. And we found g of 3. G of 3 up here is 1, and g of -2, where was that? G of -2 is -1. So when we plug these in, we have f of 1 minus f of -1. And then if we look at the f functions, so going all the way back up here, f of 1 is 2, and f of -1 is 8. So we have 2 minus 8, and your answer ends up being -6. Okay, so that's that free response question. So the chart problems can be a little bit tricky. So the scoring for this one, for part A, you get 1 point for your answer with justification, so saying x equals 1 is the only place where we would have a relative min, and then something about how f prime changes from negative to positive. For part 2, you get 1 point for recognizing that f prime of 1 minus f prime of -1 is equal to 0, and then 1 point for your explanation saying that you use the mean value theorem or Rolle's theorem. Part C, you get 2 points for h prime of x, which was 1 over f of x times f prime of x. I'm guessing if you just had 1 over f of x, you'd get 1 point, but you need 2 points from the chain. And then h prime of 3 then is going to be 1 over 14, so 1 point for the answer. And then part D, recognizing that you can do the fundamental theorem of calculus to get the f of g of x, and then 1 point for the answer of -6. All right, 2014 question number 6. So this is a differential equation problem. We've done plenty of these, so I expect that you guys are all pros at this. So it says, consider the differential equation dy over dx equals 3 minus y cosine of x. let f of x be the particular solution to the differential equation with initial condition f of 0 equals 1. So we're very used to seeing this setup. Part A says a portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So I don't actually have that on here. So I'm going to go to the answers page so you can see it. So they would have had this slope field, but not with the curve drawn in. And this is a little bit different. We haven't done one of these before in class. We talked about it in our notes, but we didn't do it as one of our homework problems in class. All right, so here's the point 0, 1. So you would just want to make sure that every time you see one of those slopes, you're curving along the slopes. It's kind of hard to describe. So see how we had negative slopes here, but then all of a sudden we had positive, so that's showing us that we're curving back up. Okay, so that would be what your solution curve would look like. Okay, so part B says write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So again, line tangent, we need the slope, and we need a point. Okay, so our point we have 0, 1. The slope is going to be whatever f prime of 0 is equal to. So f prime of 0 is the same as plugging into our dy over dx, plugging in x equals 0, right? So we're going to have 3 minus y times cosine of 0. So we're close, but we don't have the y value. Well, what is the y value? It's at that point 0, 1. So I'm going to write x equals 0 and y equals 1. And I'm going to replace that minus y with minus 1. So I end up getting 2 times whatever cosine of 0 is. So on our unit circle, cosine of 0 goes out 1 unit, so I'm going to have 2 times 1. So your answer is 2. So that means our equation of our tangent line uses m equals 2, and it uses the point 0, 1. So just like algebra, we have y minus 1 equals 2, x minus 0. So you could write it in point slope form, or you could recognize that 0, 1 is a y-intercept and just say y equals 2x plus 1. Okay, typically if it's a harder point, like not the 0, something, not a y-intercept, then you would want to leave it in that point slope form. All right, and then part C, of course, we knew it was going to ask for the particular solution to the differential equation. So we're going to go ahead and separate our variables. So we're going to leave the cosine of x on the right side, and it's joined by the dx. And then our 1 over 3 minus y is on the left side, and that's joined by a dy. And we integrate. So when we integrate, the right side is easy. We know the derivative of cosine is negative sine, so the antiderivative of cosine is positive sine. But the left side is a little bit more challenging. Many of you guys will know right away that it's going to involve the natural log of 3 minus y, and most of you guys will know that you gain a negative as well. So where does that happen? Because our u is 3 minus y, and du is going to be negative 1 dy. So you get a negative 1 du replaces the dy. So we would replace, and we'd have 1 over u, and dy becomes negative du. So you could do all of that work, but I think most of you guys are pretty good about doing that part in your head. So then we have negative natural log of 3 minus, we're plugging in the point 0, 1. So 1 equals sine of 0 plus c. Sine of 0 is 0. So we get negative natural log of 2 for our constant. So we go back and we put that in. Okay, and the AP test usually does e raised to both sides at this point. Now, I personally like to combine logarithms, so I would take that natural log of 2 over. So I would get natural log of 2 minus natural log of absolute value of 3 minus y equals sine of x, which is really the same as natural log of 2 over 3 minus y equals sine of x. So now we can do e raised to both sides, or switch from logarithmic form to exponential, basically. And we end up getting absolute value of 2 over 3 minus y equals e to the sine of x. All right, and we get rid of the absolute value by plus or minus. It's a difficult one, isn't it? And we have 2 over 3 minus y. So when I see a y in the denominator, I typically will flip both sides. I'm going to take the reciprocal of both sides. So I'm going to say 3 minus y over 2 equals 1 over plus or minus e to the sine of x, which you could write as e to the negative sine of x if you want to, if you wanted to use the negative exponent. So we multiply over. We subtract the 3. This is a hard one. And then we divide by a negative 1. So we would get y equals, we still have a plus or minus. It's like plus or minus now becomes negative plus. So I have plus or minus 2 over e to the sine of x, but then I have plus 1. And we make a decision on the plus or minus. So our original point was 0, 1. We want to be able to plug in a 0 and get 1 out. So if you plug in a 0, right, you get e to the 0, which is 1. So we have plus or minus 2 plus 1. So which one do we want? We want to be able to get a 0. Ooh, what did I do? A 0 out. Uh-oh. Oh, I put plus 1 here. What am I talking about? This isn't plus 1. This is a plus 3. I bet you guys were screaming at the screen there. Okay, plus 3. So I want to be able to plug in and get a 1 out, right? So I have negative 2 plus 3. That will give that to me. So I need a negative. So it needs to be y equals negative 2 over e to the sine of x, and then all plus 3. Okay, and recently the AP test has been going to more of these negative answers just to make sure that you did have the plus or minus in there. So a lot of times you don't get that last point because you just forget to write the plus or minus. All right, and now if it asks for a domain, we just look back at our original. Our x's, right, were never undefined. X could be anything for sine of x. So we're good there. It would be the y values that would have issues. Okay, so we don't worry about the y's. Our domain is all real numbers. So you could put that on there if you would like to, but you do not have to. All right, so the scoring for this. So you get 1 point for having the correct solution curve. You get 2 points so per part B for 1 for the tangent line equation, which is, oh, did I skip part B? I think I did it. Yes, the tangent line equation, which is y equals 2x plus 1. And I forgot to do the approximate f of 0.2. Oh, bad math teacher. So if I'm approximating f of 0.2, then I'm going to plug into this, the y equals 2x plus 1. So I'm going to have 2 times 0.2 plus 1. And I'm going to have, let's see, 2 times 0.2 is 0.4 plus 1. So you should get 1.4. So I really missed that point, man. Didn't get a perfect. All right, so you get 1 point for your tangent line equation and 1 point for the approximation. For part 6, as you know, if you do not separate variables, you get 0 out of 6 points. If you forget your plus c, you get a max of 3 points. But going through this, you get 1 point for separating, so like this. 2 points for your antiderivative, so 1 for each of those. 1 point for remembering a plus c. 1 point for plugging something in to find what c is. 1 point for correctly solving for y. Okay, so you would get a total of 6 points for that, just that part.